This topic will focus on public versus private responsibilities related to stormwater management, flood prevention, and sewer backup. The learning objectives of this topic is really to try and provide a brief explanation on the differences between public and private responsibilities when it comes to flood prevention and stormwater management, and give you some basic information to help guide homeowners when they have flood-related issues with either adjacent landowners or municipal government. I'm briefly going to talk about some of the key lot level flood risks and potential solutions at the home, but I'm not going to get into too much of that because there'll be other presentations later on over the next week and a half that will address this in greater detail. So some things to think about. In your online material, you have been provided information about such major storm events that have helped shape engineering and planning practices, what's changed over the years related to addressing stormwater management and flood prevention, and why it's important to help private property owners assess their risk when it comes to flood prevention. So we always start with this. It's a tried and true graphic, and essentially I won't get into the details too much, but I think some takeaway messages that I want to provide to you is that, especially over the last several years, there's been significant changes to our climate induced by human beings, basically. And that has influenced the climate in a lot of ways, particularly related to the hydrological cycle. So as water evaporates off of hard surfaces, that increases the amount of energy that is transferred into the atmosphere, and it influences how dramatic and how dramatic the storms are becoming and the frequency of those as well. Urbanization effects on the natural water cycle. You look at the top left-hand part of the screen, you'll see that the natural topography provides a great opportunity for rainfall to infiltrate into the ground. So almost 50% of the water that comes down from the sky in a natural setting would get into the ground, 40% would be evaporated, and 10% would be runoff across overland circumstances. And as you work through those various graphics, the more impervious area or the more urbanized the environment, there's less and less water that gets infiltrated and more runoff that's generated. And the implication is that runoff, and as you get down to the lower graphics, that runoff has to be managed and handled. The more urban environments create high amounts of runoff, which causes potential for overland flooding, as well as increases in pollutant runoff into watercourses. In your online material, we've given you a lot of detail on 3 major storm events. I don't want to review them in great detail here, except to really focus on the implications that each of these events had on communities. In the case of Hurricane Hazel back in 1954, substantial and significant flooding occurred in the Toronto area, which influenced how flood prevention was managed and handled. There was a more coordinated effort between conservation authorities and municipalities to manage where buildings were placed and how watercourses were managed in terms of the amount of runoff that they were being made to handle. In the case of the Walkerton tragedy, which happened in 2000, though this was primarily a drinking water tragedy, in other words, people consumed tainted and contaminated drinking water, there was 95 recommendations that were presented by the O'Connor Commission, of which several related to source water protection. And that, again, of course, focuses in on the rainfall that's coming down from the sky and where it ends up. Certainly, in the multi-barrier approach, which was presented as part of the Commission's results, source water protection was the beginning. That was the start of the multi-barrier approach. Included within that multi-barrier approach was drinking water treatment. In 2013, the most recent event that we discussed was the Alberta flood. Significant property damage was caused in the order of billions of dollars. And this had a traumatic effect on the people in each of these communities. The provincial government enacted a regulation, or an act, excuse me, to address where communities were allowed to build within floodplains, and also ensured that communities were rebuilt after the flood. But primarily this regulation is still has not been fully enacted, and there are still changes that are going to be coming out of that. But again, those three events, one, I guess if we wanted to categorize the Hurricane Hazel event, it really focused on preventing floods. Walkerton was really around source water protection, and the Alberta flood was more related to climate change. So let's talk a little bit about the necessity of managing stormwater runoff and the amount that is handled. So I just have to pause for a moment. Hello, Michael, it's Grant here. Can you just mute your microphone for a second? All right, welcome, Michael. And I think we lost Ryan along the way, but we've got a great turnout for today's event. So the necessity of managing stormwater runoff, really focusing on three key areas: water quantity, water quality, and volume reduction. So again, managing those peak flows addresses the flood prevention and erosion hazards that occur when you have large volumes of runoff. Water quality is really talking about managing that sediment and pollution control. More recently, focusing on as well the temperature of the actual runoff and how that might affect habitats and aquatic and terrestrial species. And finally, volume reduction, which is really that managing stormwater in a way that mimics the natural cycle, in other words, pre-development conditions. And that's been an important change in the approach to stormwater management over the last 10 to 15 years. I want to just go in a slightly different direction, just to try and provide you with a quick overview of the various parties that are responsible and involved in flood prevention and stormwater management. Orders of government. The Canadian Constitution is the source of government authority in Canada. It grants federal and provincial governments certain powers to regulate various issues and areas. Not surprising, more than one government has authority, or government level has authority related to flood management and stormwater management. I'm going to talk about provincial, municipal, conservation authorities, and of course the private property owner and some of the responsibilities there. So at a provincial level, there is significant responsibility related to the approvals of sewage works under the Ontario Water Resources Act, and really looks at the approvals of sewage works. And within the context of the the Water Resources Act, sewage includes both sanitary sewage as well as stormwater itself. The provinces are permitted to delegate some of their authority to municipalities and conservation authorities, and we'll talk a little bit about that in a second. But essentially, it's the province that has the overall responsibility for approvals for these types of facilities. Municipal governments, again, exercise their authority at the discretion at the discretion of the province. They're delegated through provincial legislation under the Municipal Act. They have very broad powers, able to enact bylaws that provide various services to the public, including, again, stormwater and wastewater. The Provincial Planning Act and the Building Code also has stipulations. This is a provincial level. It has stipulations and allows or requires municipalities to consider stormwater management as part of their mandate as well. So in the case of the Planning Act, when we're talking about the implementation of new developments in municipalities or the institution of new buildings on private property. Conservation authorities are a very special case to Ontario. They generally were enacted in the late 40s and early 50s, particularly came to the forefront after Hurricane Hazel, and essentially focus on the prevention of flooding. They are overall responsible for knowing and identifying where flood-prone zones are and the various flood zone mapping that's required as well to ensure safety of public property and private property as well. Ontario Regulation 9704 provides them also authority to regulate development activities adjacent to water bodies in the Great Lakes and St. Lawrence River system, as well as inland lakes that might be affected by flooding and erosion. And finally, the last stakeholder in this circle of responsibility when it comes to flood prevention is the private property owner. Certainly, even with various levels of government, maintaining or ensuring that there are regulations and standards associated with stormwater management and flood prevention, the private property owner also has a responsibility within their own property or on their own property. Though efforts are made by various levels of government to ensure that weather and runoff, I guess I should say, is handled and managed appropriately, there still are unforeseen circumstances that the private property owner needs to be aware of and to prepare for. As there are more frequent severe weather events, homeowners need to identify areas of flood risk around their property and actually mitigate that risk. It's not just simply good enough to blame it on certain levels of government or someone else. There is a certain responsibility there as well for them. So I'm just going to take a pause here, and are there any questions or comments at this point in time? And if so, you can unmute your mic and chime in. I see that Zena has a question she put into the chat. Yes, the presentation will be posted. As soon as this presentation is over with, you will receive a link to the presentation. Okay, I'm going to continue on. So let's talk a little bit about some of the stormwater management approaches. Again, just to recap a little bit, there have been major storm events that have influenced, excuse me about that, have influenced how we manage stormwater. So I'm just going to have to take an email. Excuse me for a moment, please. Okay, I'm back. Sorry about that. One of our participants has not been able to log in, so I was just checking in there. Okay, so let's start again. Stormwater management approaches. What the next few slides are going to try and address are some of the practices that are in place now, and some of the practices that are, I guess, emerging over the last few years. How public education influences private property owners and some of the incentives that municipalities particularly provide to property owners. All right, just as a recap, again, urban effects on stormwater runoff. As more development occurs, we get naturally more runoff, or at least the past practice has been, if we've got impervious area, we try and capture that runoff and get it as quickly as possible away from the community and off to a water course or lake where it's not going to do as much damage, so to speak. However, there are other implications when you're doing that, and drawing runoff, higher runoff volumes away causes erosion. It also causes pollutants to get into water courses and potentially as well into groundwater supplies. So this type of approach, though worked well for the first 40 years of development, as of the 1980s, the thought process has changed a little bit, and that further there continues to be changes to the approach. So in the 1980s, or up to the 1980s, excuse me, it was really focused, stormwater management was really focused on flood prevention. In between the 1980s up into 2000, there was a lot of focus on water quality improvements. In other words, trying to extract or reduce the amount of pollutants that are ending up in water courses. And, you know, after about 2000, there was much more dialogue around climate adaptation and ways to try and mimic the natural water cycle and really try and capture runoff, or excuse me, the rain that's hitting the ground at the source or at the lot level. So just to highlight the approach that was taken, you know, we can debate in terms of when the dates were, but generally up until about 1960, the upper graphic shows how, when water was managed or stormwater was managed, it would be essentially captured either in combined sewers or in downspouts that feed sanitary sewers. And this causes either overflows and overland flows or sewer surcharge or sewer backup. When a lot of rainwater gets into sanitary sewers when it really shouldn't be there, it can cause problems. And we'll talk a little bit more about that. After about 1960, there was much more emphasis placed on separating flows. In other words, taking the rainwater or stormwater and separating them into different drainage systems, capturing minor storms, say within small ditches or in the road allowance between the curbs, and directing them away from the development or property. And major storms are handled in different ways with larger facilities such as stormwater ponds or larger drainage ditches. Furthermore, there was more emphasis placed on controlling lot grading. So what that means is that compared to pre-1960, water was directed away from buildings and towards more controlled ditches or swales. In previous to 1980, a lot of subdivisions didn't have positive drainage away from buildings. And so some of the challenging areas of older communities are ones where there's very little lot grading available, and that's shown in the upper graphic. So let's move on and talk a little bit about overland flooding. Again, overland flooding occurs when the capacity of municipal storm systems or combined sewer systems is exceeded. So they're designed for a certain depth of rain, a certain storm event, and the pipes and the systems cannot be designed necessarily for the maximum event that is possible. They're designed for the most realistic or frequent event that would occur, and in that case, it would be something like a 1 in 5 or 1 in 25 year event. So municipalities, though they are able to manage rainwater and stormwater, they also compensate for this inability, or well, it just would be too costly for them to do it, with ditches and swales, ways to direct additional flows away from properties. And even in these circumstances, this can cause flooding in and around private properties. If these overland flow routes become overtopped, then this water would likely end up in people's basements. So making sure, and I guess a key element here is making sure that these overland flood paths or routes, like ditches and swales and curbs, are maintained is extremely important. And it is really a combined responsibility in a lot of respects for both the private property owner as well as the municipality. I mean, certainly municipalities are required to maintain these systems, but the property owner is probably the one that's most likely going to be noticing debris or blockages in these systems. So what's the difference between wastewater and stormwater? I mean, I'm sure a lot of you probably already know this, but just to be clear, wastewater is different from stormwater in that it's generated through the pipes from private properties, and they're directed to a centralized wastewater treatment plant. And what I'm talking about here is again, municipalities or urban centers which have centralized plants. If you're living out in the country, that's usually a different situation. You'll have a septic tank, but in the context of what we're dealing with here in this course, it's wastewater is screened, the solids are removed, and the remaining water is disinfected and discharged to a river or a lake. During rainstorms, e.g. wet weather, and you may have seen that term on a previous slide, wet weather conditions can cause stormwater to enter the sanitary pipe network or the wastewater pipe network, and this will overload the system or may overload the system, and again causes sewer backups and sewage potentially to bypass the treatment plant into the waterway. This occurred actually in the 2003 flood in Peterborough, where the system was so inundated with stormwater, it actually created or caused wastewater just simply to go right through the treatment plant because there was such huge volumes of sewage and water being passed through pipes and basically overtopped the wastewater system. So sewer backup is again different from overland flood conditions. A sewer backup is caused in conditions where stormwater has entered the sanitary system, has caused potentially surcharging of the pipe, which essentially means it turns from a gravity-fed system into a pressurized system, where the sewage is actually pushed up through the pipes that are underground and into private property pipes, or up into floor drains or toilets or sinks that can cause sewage to enter the basement. Many cities have combined sanitary sewer systems. Again, they're legacies from the post-war boom, the post-Second World War boom, and again, it was considered to be best practice at the time. But we realize that as our cities have grown, this has caused these systems become overloaded and inefficient in a lot of respects. If we can separate stormwater away from the wastewater and keep that out of the sanitary sewer system, two things happen. One is we reduce the amount of sewage that has to be treated at a plant downstream, and two, we can reduce the risk associated with sewer backup or surcharging of these sewers. So we'll talk a little bit more about this later, but there are incentive programs that municipalities encourage property owners to disconnect eaves, trough, downspouts, and foundation drain connections to sanitary sewers. So some of the engineering approaches that, sorry about that. Some of the engineering approaches that municipalities across Canada have worked on to mitigate basement flooding include evaluating their sanitary and storm systems, separating these combined sanitary and storm sewers, and prioritizing where that work can take place. Typically, where there's the most number of basement flood concerns or drainage issue concerns, municipalities will focus in on that. Decreasing infiltration and inflow into the sewers, so essentially fixing either cracks in the pipe or the manholes, the underground system, which is infiltration, or reducing the inflow, which is really disconnecting those downspouts that might be connected from a homeowner or a house to sanitary sewer itself. And the last point is really conducting preventive maintenance, so making sure that we just don't put pipes in the ground and ignore them for 100 years, going out on a regular basis and making sure that they're cleaned and functioning properly is extremely important. So this graphic just shows you, it summarizes some of the issues that I just finished discussing. So sources of inflow and infiltration, those are either, again, connections to the sanitary sewer system or breaks or cracks in the piping system itself. So if either one of those two things can be reduced or eliminated, it's going to reduce the amount of either groundwater or stormwater that will be getting into the sanitary sewer system, and thus reducing sewer backup risk. And so the house on the left is improperly connected, and the house on the right is better connected. Some of the other best management practices I'm just going to quickly highlight. We don't need to get too much into the details and the nitty-gritty, but so in other words, in order to try and address some of these issues of either controlling volume or improving the quality of the stormwater runoff, municipalities have implemented a series of best management practices that, again, started in the 1980s and, again, either address runoff volumes or improvements to water quality. Overall, the stormwater management treatment train, we'll talk a little bit about that, which really involves what we can do at a lot level, what we can do at a conveyance level, and what we can do at really that discharge point before it reaches the waterway. An example is a stormwater management pond. Again, they're typically upstream of waterways. They try and either reduce the volume or improve the water quality of that runoff before it gets discharged. So source or lot level controls, I mentioned just a couple of examples. And again, this is at the point of origin. In other words, where does the rainwater hit the ground? And what can we, what happens to it once it does hit the ground? Is it absorbed? Is it captured and then directed somewhere? So those are two key and very important aspects. The conveyance controls are things like the pipe or the ditches or potentially a naturalized channel. This is the pathway. This is how the water gets from A to B. And then finally, the end of pipe or discharge controls, which is the receptor. These are usually large facilities as you get further and further away from the source of the rainfall, or the source of the runoff, the source of the runoff, the more and more complicated these systems become, and thus the expense goes up. So if runoff can be controlled effectively at source, it actually will help to improve downstream costs and maintenance issues. You'll hear about low impact development, and this is again an evolving and emerging trend, a more current stormwater management, stormwater best management practice, and focuses again trying to capture that runoff at source. Very good guides on LID SWM, or in other words, Low Impact Development Stormwater Management Guide, which was developed by the Credit Valley Conservation and Toronto and Region Conservation Authorities. This will be referenced in your lessons coming up, I believe, in the next lesson on private property lot level control. It's a great guide, and it gives you a lot of useful information about what LID is all about and some of the practices that are being considered and have been applied as part of the stormwater management treatment train approach. There's no doubt that LID has its drawbacks, as well as some of the positive things, such as trying to reduce stormwater runoff. So I'm just going to give you a few examples, just again, not to try and get into too much detail in such a short presentation, but some of the best management practices, again, really can be generally quantified into quantity controls and quality controls. Things on the quantity side would be things like stormwater management ponds, which hold runoff and release it over a certain period of time. Parking lot storage, in other words, just capturing the runoff and then slowly releasing it after a major storm. Same thing with rooftop storage. Another way to handle quantity is really to capture the water and put it back into the ground with infiltration galleries, which are basically underground structures that are designed to capture a certain amount of stormwater runoff from roofs, as an example. Or simply underground storage, so just capturing that water and potentially using it for rainwater harvesting. On the quality side, again, you can have stormwater quality ponds, which are designed to allow sediments or pollutants to drop out of the water and the runoff before they get discharged. Oil grit separators are typically installed on private properties where there's a likelihood of pollutants, significant pollutants, being picked up by stormwater runoff. What this essentially tries to do is remove the grit and the oil before it gets discharged to the municipal sewer system. So the municipality does not have to manage that. It's actually managed by the private property owner. Then there's other management techniques, such as sweeping plans and salt management. So let's talk a little bit about education and incentives. As I mentioned, there are responsibilities for private property owners, and in a lot of ways, to try and encourage or reduce that risk to private property owners, sometimes you have to encourage them with incentives to get them to do the right thing. And this could involve just simply educating them about basement flood risks, but typically we need a little bit more than that. We need the property owners to take action. So some of the social approaches, I'll say, are designed to increase public awareness around flood hazards. This program, the Home Flood Protection Program, is one example of that. And again, trying to get homeowners or private property owners to take and adopt certain practices. So looking around your property, understanding how the lot grading works. Do you have low spots in your property? Do you have water coming into your foundation? In other words, is the grading improperly set up? A little bit more costly, but nonetheless important, are things like installation of backwater valves or installation of sump pumps and backups for sump pumps, disconnection programs of downspouts, and basically taking them apart and allowing the runoff to run across land. These are all examples where homeowners can take positive action, and municipalities are interested in trying to encourage them to take that action. Sometimes municipalities have to enact bylaws and inspection enforcement, but again, the smartest way is to educate homeowners about compliance and the importance of compliance, but they have to be informed of the bylaws, and sometimes public outreach is necessary for that. Typically, that's necessary. And also, as I mentioned, incentives. So some of the typical improvements I've talked a little bit about already. So installing a backwater valve. This helps to reduce sewer backup problems, and in other words, having that sewer surcharge or pressurized causing wastewater to come back into the home, having a backwater valve will prevent that problem. Severing downspouts and capping of those storm sewer connections between the weeping tile and or the downspouts is another way of doing it. Installing a sump pit drainage system with appropriate backup is also important. I think I'm just going to check to see how our chat's going. Okay, no questions so far. I'll just pause. Are there any questions?
Hey, Grant, I had a question for you.
Sure.
I was going back to Burlington, going back to the combined sewer system. So just wondered if you had any idea of whether or not Burlington had a combined sewage and stormwater system, or if they have separated it, because it is a fairly old city.
I don't know specifically. I would guess that they would. Most municipalities do have combined systems, and especially in the older portions of the municipality. I don't know specifically whether or not whether Burlington has a combined sewer replacement program, and again, that's typical of most municipalities in this day and age. If they have problems like that, they want to get them resolved. Sometimes they do have kind of an approach or a phased approach to addressing this, so that again, focusing on properties or areas or communities within the municipality that have had high degree of flooding or sewer backups that are occurring. So I would say, in summary, yes, they do, and two, they probably are doing something about it.
Okay. Yeah.
Okay.
I would assume that's pretty standard across the board then. Yeah.
I mean, with time, certainly as municipalities improve their infrastructure, those combined sewers will eventually be eliminated. But again, typically municipalities only have a certain amount of funding available to address these issues.
Right. I had another question too, not necessarily directly related to this, but for the summary test that's at the end of this unit, is there a particular deadline to get that done by?
No, there's no deadline. You can take it at any point in time. I would suggest that once you're finished this particular lesson, that you can just go right in and complete the quiz.
Okay. Perfect. That's it for me.
Okay. Anybody else? Okay. Well, we'll continue on then. So typical improvements, as I mentioned, are listed here. There's more in the online material that has been provided. But just in summary, some of the program rebates, again, are to try and encourage property owners. This doesn't obviously cover the entire cost to either do a disconnect or a replacement or other improvement. It is intended just to try and encourage property owners to to take the right action. So I'll give you a tangible example. When I was working at the City of Kitchener, we had a sump pump disconnect program where, again, or it wasn't a sump, yes, it was a sump pump disconnect program, sorry, where people actually had sump pumps and the piping connected directly into the sanitary sewer that ran out in front of their property on the street. We encourage property owners to dig up and disconnect that connection and then reroute their sump pump discharge overland through a swale or out onto their front lawn. We were only able to cover a certain portion of that cost, and we also had a waiting list. So we had a certain budget of, say, $50,000 or $100,000 that only allowed a certain number of properties to be done in any given year. So that's an example where municipalities have set aside money to try and get this problem resolved, but it doesn't certainly happen overnight. And so there's obviously other conditions that sometimes are required to be met by the property owner. Just listed a few of these. This typically only applies to existing homes, not new homes or homes that are in the planning stage. This is to try and address issues in existing neighborhoods where there's known problems to get addressed, whether it be through sewer backup issues or overland flooding. Again, typically there's a certain completion date that's required. There's a certain limit on the financial contribution by the municipalities. Building permits would have to be obtained. If it's a plumbing issue, that's typically standard. And again, as I mentioned, in the case of Kitchener, we had a first come, first served basis where we only had a certain amount of money every year to allocate to it. Now, the city at that time implemented a stormwater utility which allowed the municipality to generate additional revenue to put towards more of these issues over a longer period of time. So I'm going to summarize the presentation here. It's an evolving practice. The programs continue to evolve with time, but certainly municipalities have been spending a lot of their time on looking for ways to reduce sewer backup and flooding within their communities. The science and the management techniques have changed, and there's more of a focus on the overall health of rivers and streams and fisheries. And again, it's not all about how fast we can get rid of the water in an urban environment, but really what the quality of that water is once it eventually gets discharged. However, with more frequent heavy rainfall events due to climate change, there will be an additional burden placed on infrastructure, and there'll be an increased occurrence of damages because of sewer backup. And so there's a heightened sense of concern around looking for ways to either improve the urban infrastructure or look for ways to reduce the amount of risk that private property owners are faced. Private property owners have an important role to mitigate that damage, and this is going to be part of your role as an assessor, is to try and get those messages across, demonstrate the value, and to try and eliminate that risk for private property owners. So what's the future of stormwater and flooding? Well, a couple of quotes, I guess, from some pretty smart people, not myself included. But again, as climate change increases, there's going to be more frequency and more intensive storms that will be happening, and you just have to think about this spring and how wet it has been, not only how wet, but how often some of the thunderstorms that have rolled by over the last little while. And certainly the frequency of the major events is becoming more and more short between the times that they happen. So in summary, thanks very much. This brings to the conclusion the presentation. I'd certainly be happy to try and address any questions that you may have.